All right, so the good news is this will be the last of the videos that is giving you new information leading us up until our exam next week. So on the board, you currently see all of the things that you should understand and know about, except for the part that is in red in the lower right-hand corner. You should know what a chemical equation is. You should know that the reactants are on the left, the products are on the right, and after each of the substances involved in the equation or involved in the reaction, there should be a phase of matter being listed. S for solid, L for liquid, G for gas, AQ for aqueous, which means that thing is dissolved in water. You should know how to balance an equation. You have to have a properly written chemical formula for all of the reactants and products, and the only thing you're allowed to do is change the coefficient. That is the only thing you can do. You cannot change the formula. You can't put anything else in. You can only change the coefficients. You should know how to classify reactions. There were 5 types. There were synthesis, also known as combination. There is decomposition. There is single replacement, and there is double replacement, and there are combustion. From those 5 types, you should also be able to predict the products as we have discussed in the previous videos. You should know that there are 4 visible evidences that a chemical reaction is occurring. They are either bubbles are forming, there is a color change occurring, there is a solid forming, that's called a precipitate, or there is energy being absorbed or released. Now the difference with that is you might not be able to visibly see that happening. If you react 2 things into a container and it released energy and got hot, or it absorbed energy and got cold, you would not be able to see that unless you had a thermometer inside of your reactant or inside of the vessel that was taking place. That's okay. Most of the time we would tell you, okay, if it doesn't look like anything's happening, make sure that you're checking on energy. And the last thing is the 4 driving forces, that there's a formation of 3 different things, either formation of gas, formation of water, or formation of a solid. And then with those 3, we have not talked about the details about forming a solid. And the 4th driving force, which we don't really see, is the transfer of electrons. There's no visible evidence of that. That's only seen in the balanced equation, and that's beyond what we're talking about in our class right now. So the next thing to be aware of is that the formation of a solid, that red that we had in the corner, the driving force, formation of a solid has another name. It's called a precipitation reaction. What is happening is 2 aqueous solutions get mixed together, and a solid falls out of the solution. Similar to what we would say rain is a form of precipitation. Water droplets condense in the clouds, and they fall out as water. Well, in this case, the 2 aqueous solutions are being mixed. Those 2 things combine in a double replacement reaction. They trade partners, and one of the things falls out of the solution as an insoluble substance. So hopefully you recognize this prefix in for not. Something is insoluble means that it is not soluble. Soluble is a word that means that substance will dissolve in water. All of this that we are talking about is only talking about in aqueous solutions. We're talking about water, all right? There are things that are soluble in other liquids. We can dissolve things in acids, but if we're looking at just water, we need to know if they're simply soluble or if they're insoluble. So in order to know if a reaction occurs, you need to know what's called the 6 solubility rules. So for our class, these are the simple solubility rules. These are the only ones we really care about. And so I will go through them. You will probably want to write these down. Nitrates, that means a compound that contains nitrate as the anion, will always be soluble. Sodium nitrate, iron nitrate, copper nitrate, zinc nitrate, they will always be soluble in water. They will dissolve. Rule number 2 is that the group 1 cations, meaning lithium, sodium, potassium, rubidium, cesium ions, when they're involved with any other substance, they're going to be soluble. Now let me pause for a moment. This list, as we have them here, is what we would call an order of operations. When you go to determine whether or not a substance is soluble, you have to go in order. If the rule applies higher on the list, that is the rule that is going to take precedent. That's the one we care about. That's the one that matters. So nitrates being soluble, it doesn't matter what the element is that's with that nitrate, it will always be soluble. The group 1 cations, meaning lithium, sodium, potassium, rubidium, cesium, they are always soluble, including an ammonium, which is not a group 1 metal, that is a polyatomic ion, but since it's a +1 charge, those are also always soluble. Doesn't matter what they react with. When we get to rule number 3, we start to have some exceptions. So we call them the halides, or the group 17 anions. If you remember, we said that the group 17 elements, fluorine, chlorine, bromine, and iodine, are called the halogens. And for an anion, when you drop the ending and add IDE, that becomes the halide, halogen, halide. So the group 17 anions are usually soluble. The exceptions, there are 3 major exceptions for our class, and those are silver, lead, and mercury with those charges. Silver with a +1, lead 2, and mercury 2 ions. If those things react with a chlorine or react with a bromine or react with an iodine, they are going to be insoluble. They will precipitate out. They will be solids. So we're not talking about Ag, Pb, and Hg by themselves, but we're saying when those 3 elements, silver, lead, and mercury, react with a group 17 anion, they will precipitate out. Rule number 4 is the sulfates are usually soluble. And again, that would be any solution that has sulfate with a few exceptions. Calcium sulfate, barium sulfate, strontium sulfate, and lead 2 sulfate are also insoluble. You experienced this one in the lab last week. When you mixed calcium chloride, which is soluble, calcium is a group 2 metal, chloride is a halogen, and it's not one of the exceptions, so calcium chloride is soluble. When you mix that with sodium sulfate, again, sodium is a group 1 cation, so the sodium sulfate is always soluble. We got calcium sulfate as a product. Calcium sulfate is insoluble, and that's why it got cloudy. Barium sulfate, strontium sulfate, and lead sulfate, they would be the same thing. They would get cloudy in solution. They are not soluble. Rule number 5 are the hydroxides. They are usually insoluble, and I didn't change those the right way. Those are supposed to be the superscripted values here. Magnesium +2 and calcium, come on now, what just happened? Calcium +2, extra little plus sign in there. Calcium +2, there we go. We say that those are called moderately soluble. If you were to look at it with your eye, you would see that it looks cloudy. It would not precipitate, or it would precipitate out. We would say that it's insoluble. However, there are enough of those things dissolved that it would cause some issues later on in life. If you've ever had to take, what's it called, milk of magnesia, that is a magnesium hydroxide solution, and you can drink it. There's enough of it dissolved, but it's usually going to be insoluble in our class. Finally, rule number 6 are sulfides, carbonates, and phosphates. They are always insoluble. They will not dissolve unless they are with a group 1 cation or ammonium. So in our class, when you did the experiment, you had some ammonium carbonate, you had sodium carbonate, and I believe those were the 2 carbonates that we had in the lab. So as the soluble version, it was dissolved in water because group 1 cations and ammonium cations are always soluble. So even if we put it with sulfide, or if we put it with carbonate, or we put it with phosphate, it's going to be soluble until it trades partners with anything else. So that was why you had iron carbonate and copper carbonate that formed with those reactions, because those things are insoluble when they're with any other metal other than a group 1 or ammonium cation. That is the last of the new things that you need to know about. What I will do is either Wednesday or Thursday, I will come back through this video idea and I will give you one last review video, more like here's some sample balancing equations, here's some sample predicting reactions, and here's some sample solubility rules. And from there, you should be prepared for the exam that you will take on Monday. The exam on Monday will be on all of those three things that we had at the very beginning. Not 3, all of these things. Chemical equations and what they look like, how to balance an equation, how to classify and predict reactions, the visible evidences, and the driving forces. If you know all of these things, you will be ready for the exam on Monday. With that, we will do another experiment later this week, and we have a couple Moodle assignments that you should be working on to make sure that you're all prepared. And with that, I hope that you have a wonderful week. We will continue to work on our lab materials and get you ready for your test on Monday. Have a good afternoon.